Good morning. Well, it's morning for you. It's not for me, I'm afraid, because I am teaching this morning. So therefore, I am recording this on Wednesday evening. But it's available for you to watch 10 o'clock as normal this morning. And format is exactly the same. Okay, let's get started. You know the score, but just for any new people, 2 pens. You've got a different colour for marking. A ruler, if you have one, so you can set your work out nice and neatly. Draw a margin down the left-hand side so you can number your questions. You do not need one of these. We don't need a calculator. There's a reason for that coming up. If you have got a notebook, maybe your maths scorebook, that's really handy because it just means you can set out your work super neatly. So why do we not need a calculator? You all know this. If I was live, you'd be putting it in the live chat right now. We need our brain. We need our focus and our attention. Just half an hour of your concentration every morning at 10 o'clock. All right, we're going to get started by just running through the answers to yesterday's review question. But because this is not live, if you've not yet had a chance to do so, then can you just make out your 10 by 10 grid? So pause it, draw out your 10 by 10 grid, and then you can be crossing the numbers off. We cross off 10 numbers a day as we do our questions at the start of each lesson. Okay, so just get that. There you go. So you don't have to see my face. All right, now let's do our answers to yesterday's review questions. So we have question 1. The factors of 100, there are quite a lot. We have 1, 2, 4, 5, 10, 20, 25, 50 and 100. And remember, I tell you to write them in a table form as factor pairs. So you'd have 1 and 100 together, 2 and 50, 4 and 25, 5 and 20. Hang on a minute, 10 doesn't have a pair. That's because 10 squared gives us 100. 100 is a square number. Question 2, first 5 multiples of 100. So we're looking at our 100 times table, 100, 200, 300, 400, 500. We have some fractions to put in order. These are quite tricky. I'm going to be going through an explanation on these later. So we have 1/2, 2/3, 3/4, 4/5, and 5/6. That is a Key Stage 3 challenge question. Rounding question 4, 23.672 to 1 decimal place is 23.7. The 6 gets rounded up to a 7 by the 7 in the 100ths column. The probability of getting 1 head and 1 tail is 1/2. We looked at those probability questions on the board yesterday. Okay, now for some work from you. Starting off with part 1. Let's go. Two minutes. 30 seconds to go. Part 2. Thirty seconds to go. Part 3. Thirty seconds remaining. Okay, your time's up. Let's go through the answers. Remember to mark them as you go through with a different colour pen if you have. Total up your scores, and then if you can put your scores into the chat, please do so. If not, I will collect those scores on Friday. So part 1, let's go through the answers. Question 1, 57 is not a prime number. Remember, I told you this trick. If you add 5 and 7 together, you get 12. So 12 is a multiple of 3. Therefore, 57 is in the 3 times table. Question 2 is 24. Question 3, 67. Question 4 is 12. Question 5 is -8. Question 6 is 2. Question 7 is 8,189. Question 8 is 2/3. And the parent versus kids challenge worth 2 marks. The probability of getting a double 6 is 1 out of 36. So 1/36 as a fraction. Part 2. How many factors does a prime number have? It has 2 factors, only 2 factors, 1 and itself. Question 2 is 48. Question 3 is 1 and 2. Question 4 is 44. Question 5 is 4.94, but remember we round it to 1 decimal place, which gives us 4.9. Question 6 is 0.008. Question 7 is 2. Question 8 is -11. And the 2 missing numbers in the sequence, if you look at the pattern, it goes up by 45 each time. So the missing numbers are 110 and 290. Finally, part 3. Okay, we're rounding to 2 decimal places. The answer is 3.75. Question 2 is 614. Question 3 is 25. Question 4 is 92. Question 5 is 66.936. Question 6 is -33. Question 7 is 5.094, but remember we're rounding to the nearest whole number, so it will be 5. Question 8, yes, because 11 multiplied by 12 gives us 132. And the parents versus kids challenge, the fractions in order are 1/9, 1/8, 1/6, 1/5, and 1/4. That is a 2 mark question. Fantastic. So those in total are out of 30. Please total up your scores. If you can put them in the chat, please do so. If not, keep your scores for tomorrow and I will collect them in then. Right, let's look at our Beat the Clock board. Let's see if we have some numbers that we can tick off. Hopefully we have another 10 numbers. Right, first one was question 1, part 1. The number that was not prime was 57. What next? 24 was the answer to question 2. 67 has gone. 12 has gone. -8 has gone. 2's gone. And that's it for part 1 because all the other numbers are too big. Let's take a look at part 2. So I don't have my assistant today, do I? Because she's in bed. So, right. Prime number 2 had 2 factors. So we've done that one. 48 is question 2. Let's pop that there. Question 4, the answer was 44. Very good. Okay, question... Oh, where are we up to now? 2 we've done, 11 we've done. Okay, that's part 2 done. Let's move on to part 3. So let's see, 25 was the denominator in the fraction. That was the answer to question 3. 92 was the answer to question 4. Have we done that? 92. Okay, so what else? -33. Well, let's have 33. 5 was the answer to question 7 because we rounded to the nearest whole number. That's question 5. And that's it. We're done. Brilliant. Okay, so we've now got, hopefully, if I've counted correctly, there should be 20 numbers covered up on our board. So 80 still to go. So 8 more lessons before we fill this up completely. Let's do some learning. Right, so I said we were going to start by looking at some fractions. We didn't get a chance to look at those questions yesterday. So we're going to take quite a little bit of time looking at ordering fractions. These questions come up at Key Stage 2 level in the SATs in Year 6. They also come up in Year 9 as part of the Key Stage 3 exams. And some of the tricky ones you'll find on a foundation paper as well. Now, bear with me because I'm getting a warning to say that my battery is about to die on the laptop. So hold on while I plug. Hopefully I can do that. What happens when you try and do 2 lessons in one day? Your technology starts dying on you. Okay, all right. So hopefully that's going to work. So we're going to put a little title here of ordering fractions. If you have your ruler, please underline it so you're setting it out nice and neatly. Ordering fractions. And the fractions we were given were 1/5, 1/9, 1/4, 1/8, and 1/6. Okay, always check when you get a fractions question, an ordering fractions question, that you're doing it in the right order, because sometimes you'll be asked to do smallest to largest, sometimes you'll be asked to do largest to smallest. Make sure you do it the right way around. Okay, so we want the smallest fraction possible here. Some of you may have used one of these. Okay, it's called a fraction wall, and it's brilliant because it shows you, you can just see by looking at it that a half, hopefully you can see that okay, a half, which is right towards the top in red, is much bigger, for example, than an 1/8, which is pale blue, or a 1/12, which is purple at the bottom. So it's a really, really good way of showing you how fractions change. So effectively what we're saying is the denominator is the number of pieces, if you like. If it's a pizza, the purple one at the bottom, I've got to share my pizza between 12 people. So you're only going to get 1/12 each. But if you're at the top and you're having the red pizza, you get half of it each because you're only sharing it between 2 people. Okay, so hopefully you can see by looking at that, if all of your numerators are 1, the bigger the denominator, the more pieces you've got to share your pizza, or more people you've got to share your pizza between, and therefore the smaller slice you're going to get. So if we look at our question here, all of our numerators are 1. So the bigger the denominator, the more people I've got to share my pizza with, and therefore the smaller piece I'm going to get. I'm not going to draw them all out. I'm just going to illustrate it with 2. If I look at this one here, 1/4, here's my pizza. I'm sharing it with 4 people. That's what a quarter looks like. If I do an 1/8, same pizza, hopefully, it's good enough. But this time, I've got to share it between 8 people. And even though my drawing's a bit wonky and not very accurate, hopefully you can see that a quarter is bigger than 1/8. So now I don't need to do loads of work making the denominator the same. I can just look at it and say, right, I know because all my numerators are 1, the smallest one is going to have the biggest denominator because I'm sharing it between the greatest number of people. And I'm going to tick them off as I go to make sure I don't miss any. 1/9, 1/8. If you're doing this in a test, use the information, tick them off. You don't want to do all the hard work, miss one out, and not get the mark. 1/6, 1/5, and finally 1/4. So even though a quarter is quite small, it's the biggest fraction in our list. Okay? Not too bad. Now I'm going to make it a little bit harder for you. I'm going to do another example. I'll do it on this side of the board. And this was your review question from yesterday. This is still ordering fractions. You don't need to put a new heading in, but we've got numbers or fractions which are perhaps harder. Let's have a look and see. We've got 5/6, 4/5, 3/4, 1/2, and 2/3. Now, on first inspection, this has got to be harder, right? Because I haven't got a numerator of 1. Well, I haven't, but there is something I can do. If I've got a fraction wall, I could use that to help me. That would definitely help. If I don't have a fraction wall, I need to think about it a little bit more. And this is why I said these questions would be at Key Stage 3 level. You might even see one sneaking up at Key Stage 4. But I'm showing it you because I reckon we can do it. So hopefully you can see that if I've got 5 slices out of 6 in my pizza, if I add on 1 more slice, I'm going to get a whole pizza. Okay? If I've got 4/5 of a pizza, if I add on 1 slice, I'm going to get a whole pizza. 3/4 of a pizza, I'm going to add on 1 more slice. 3/4 plus 1/4 gives me a whole pizza. 1/2 plus 1/2 gives me a whole pizza. And 2/3 plus 1/3 gives me that whole pizza. So hopefully now we can see that some of these numbers are closer to 1 than others. And the closer to 1 they are, the bigger they are. So what can we do? This number is only 1/6 of the way away from 1. So that must be the biggest number, I reckon. This one, 1/2, that's half away, isn't it? So that has got to be the smallest. So let's start with that one. Remember, it's the black numbers we're using, not the blue ones. The blue ones are just there to help us. So I'm starting with 1/2 and I'm going to tick it off. I now want the next smallest number. So I'm looking along here. And what I actually want is the number that is the biggest, because then it's further away from 1. That's going to give me 2/3 as my next number. I'm going to tick it off. Right, let's see. This one is 1/4 away from 1. So I'm going to do that one next. And then I'm going to do 4/5. I said 4/5 and then I wrote 5/6. I'm getting a bit carried away, aren't I? You can tell it's late. 5/6. Okay. Now, if you're in a test and you still weren't quite sure, there is nothing to stop you drawing it. Okay. You could also change all of these and make them equivalent fractions. It would take some time, but you could do that, or you could draw them out. And if you draw them out, you might be able to see visually which ones are bigger. Okay, so different techniques all work. You use the one that is best for you. That is tough. If I've blown your brain on this one, don't worry. As I said, that's really, really stretching you. Okay, let's do a little bit of work on rounding. Now, we started this off yesterday. We looked at rounding to 1 decimal place. Okay. Now this time, let's see which question we're looking at. It's part 3, question 1, and it asked us to round to 2 decimal places this time. So 3.7475, and we're rounding it to 2. And remember I said you can abbreviate decimal place by writing DP. Okay, so we just want to round it to 2 decimal places. So that means my final number is going to have 1 decimal place, 2 decimal places. So in order to work out what this final number is going to be, I need to look at my 3rd decimal place. This is probably where, if I was live, you'd be telling me right now to use my pointer, wouldn't you? So this is the only number that I'm interested in right now. I don't care. There could be loads of numbers down here. I wouldn't be interested. Don't care about that 5. Doesn't mean anything to me. So I'm just looking at my 7, sorry, just looking at my 7. My 7 is going to round my 4 to a 5. Okay, and remember, so my daughter Rose told us yesterday, 5 or more, add 1 more, 4 or less, leave to rest. And then I made a note of it here. Chloe very kindly popped a message in saying, 1, 2, 3, 4, leave it as it was before. 5, 6, 7, 8, 9, round it up on the number line. And that was new, and I really liked it. So I've written it down, Chloe. I told you I was going to use it again. So the 7 has rounded our 4 up to a 5. And that's it. We stop. Okay, now I need to find my notes again. All right, so we're going to do a quick question on probability. We've done quite a lot of work on probability, haven't we? This one, and we've talked about, every time I've mentioned probability, I've used the words sample space diagram. Scary, don't know what it means. And then I explain it's just a table showing you all the different outcomes you can get if you roll 2 dice, double 5, double 3, double 5 again. I was trying to give you a different number, double 4. Okay, the question asked for double 6. So we have 2 dice. So we have the first one, we can get 1, 2, 3, 4, 5, or 6. And then we've got the second one. And again, we can get 1, 2, 3, 4, 5, 6. Now, what I'm hoping you start to see is there is a pattern here. Yeah? We can get 1 and 1. A double 1 on our dice, that would give us 2. We could get 1 and 2, that would give us 3. And then we can fill it all in. It's going to take quite a lot of, sorry, I can't seem, I know it's late, but I can't seem to talk and write at the same time tonight, can I? And you just fill it all in like this, and you keep going, and then you get to 6 and 6, which gives you 12. Okay, so over here somewhere, you're going to get a 12. And the question was, what is the probability of getting a double 6 or getting 12? So I could fill all this in, that would be fine. Or I could say, well, I know there are 6 different outcomes this way. Remember, we wrote them up before. And 6 different outcomes this way. So that means I've got 6 multiplied by 6. I've got 36 outcomes in total. And only one of those outcomes is a 6 and a 6, a double 6. So I can say it's one outcome out of all 36 of them, because I've done 1 over 6 multiplied by 1 over 6, which gives me 1 over 36. Now, if you don't believe me, I could fill all of this in and we could count them. In fact, do you know what? Let's do it. Now, hopefully you'll do it a bit neater than this, but you get the idea, right? I'm doing it a bit scruffily. Okay, I've got 36 different outcomes here, and only one of them is a double 6. Okay, brilliant. Now, I'm wondering if I can squeeze in just one more question. It's the sequences question. I'm going to do it quickly. I'll do it on this side of the board. So it's just a quick sequences question. We're going to do a few different examples of sequences. but we're just going to do one for now. So we're just going to put a little title of sequences. All right, and the sequence was, we had a box, and then we had 155, then we had 200, 245, we had another box, and then I've run out of space, let's squeeze it on the end, 335. Okay, but the key thing is to see, this is called a linear sequence because it's going up by the same amount each time. Okay, or an arithmetic sequence. So it's going up, well, this one's probably the easiest one to see. Look, it's going up plus 45. Let's check and make sure. Yeah, this one also goes up plus 45. So if I add on 45 here, I'm going to get 290. And I can check, can't I, that if I add on 45 here, I do indeed get 335. I now need to go backwards to this side. Something plus 45 gives me 155. So I could write that the other way and say 155 subtract 45 is going to give me 110. Let's double check. 110 plus 45 gives me 155. So I know I've done it right. So that is a little introduction into sequences. Now sequences, that's an example of a Key Stage 2 question. You'd get that in your SATs in Year 6, but you will also get them coming up in Key Stage 3. They get a little bit harder. And again, getting even a little bit more harder still in Key Stage 4. So great to have a little bit of an introduction to that. Now, once again, I think I've done enough talking. I'm going to put the music on. I'm going to give you your review questions and pause it if you need to, so you can get them all written down. And I'll see you tomorrow. And don't forget, if you need to, you can pause it on this so you can get your number grid down. Thank you again. Take care.